Hi guys, so welcome today once more to Best Science Brain YouTube channel. Today we're going to take a look at NABTEB GCE November 2023 Alternative Practical Chemistry. NABTEB GCE November 2023 Paper 2 Alternative to Practical Chemistry. If you are not subscribed to the channel, or if you're coming to this channel for the first time, please move out to the channel name. You see the profile picture. Then under it, you see the channel's name, Best Science Brain. Then under the channel's name, you see the subscription button or the subscription. Tap on it only once and get subscribed to the channel for solution to examination questions and for tutorials on chemistry, physics, further mathematics, and including practicals, both O-level and A-level classes. So subscribe to the channel so that you'll be getting our videos anytime we post videos, getting our notifications. Subscription doesn't cost you anything. Subscription does not make you go broke. No, the subscription will just enable you to get our videos whenever we post our videos, important videos, so they can key in. Nobody's going to take away your data or key you for subscription. No, it's just for you to be getting our videos or notifications. So subscribe if you are seeing this video for the first time. And if you're not subscribed, you subscribe. If you don't subscribe, you'll not be seeing our videos. If you subscribe or you are a subscriber, anytime I post our videos, the notification will come to you. So it's a video that's of interest to you, then you can watch it. So we'll go to the question. Question 1A says, a student collected 150 centimeter cube of a sample of solution from swimming pool containing hydrogen chloride and labeled it B. A portion of B was standardized with 20.00 cubic centimeter portion of 0.105 mole per dm cube calcium hydroxide using methyl orange indicator to obtain the end point. This iteration was repeated 3 more times. The following results were obtained. So let's go back to the question again. A student collected 150 cm cube of a sample of solution from swimming pool containing hydrogen chloride and labeled it B. A portion of B was standardized with 20.0 cm cube portion of 0.105 mole per dm cube calcium hydroxide using methyl orange indicator to obtain the endpoint. This titration was repeated 3 more times. The following results were obtained. So before we go on to the table, we understand that the B stands for the acid. In normal titration, we normally use A as acid, but in this case, the reverse is the case. So solution B represents the acid, hydrochloric acid or hydrogen chloride acid, which will be placed in the burette. Okay, and that B is a solution obtained from the swimming pool. Okay, while the base is calcium hydroxide, which will be in the conical flask, or in which the methyl orange was added. So let's go to the table. We now have the titration table. Titration number 1, 2, 3, 4. So the first one is the rough. They were repeated 3 more times, which is 2, 3, and 4. Then final reading, final B reading, we have on the first row under 1, 19.00, under 2, S, under 3, 21.35, under 4, 19.65. Then initial B reading under 1, the first row, second row under 1, 0.00, then under 2, 2.50, then the second row under 3, 1.55, the second row under 4 is U. Then the final reading for the first theta value, 19.00, second theta value, 19.30, third theta value, 19. Okay, third is W unknown, then the fourth theta value is 19.50. We'll now go to the question that follows. I says, what is meant by the term end point in this context? What is meant by the term end point in this context? So let's go to the solution. We'll take the solution one after the other. The solution 1AI. End point is the point at which the reaction between the titrant, in this case HCl aqueous, and the analyte, in this case calcium hydroxide in bracket, is complete. It signifies that the amount of the titrant added is stoichiometrically equivalent to the amount of the analyte present. We take it once more. Endpoint is the point at which the reaction between the titrant, in this case HCl aqueous, and the analyte calcium hydroxide is complete. It signifies that the amount of titrant added is stoichiometrically equivalent to the amount of the analyte present. So that answers question 1A. We'll now go to question 1AII. 1AII says, you can see there, determine the theta values indicated by S, W, and U respectively. You can see from the table the unknown values there, S, W, and U. We are asked to determine the values of S, W, and U. We'll go to the solution. 1AII. S is 2.50 plus 19.30. That will give us 21.80 cm cube. W is equal to 21.35 minus 1.55. That gives us 19.80 cm cube. And U equal to 19.65 minus 19.50. That gives us 0.15 cm cube. We go to the next question. Number III says, select the consistent theta values from the table above and hence calculate the average volume of BUs. Select the consistent theta values from the table above and hence calculate the average volume of BUs. The theta values are the values in the last row. The values here 19.0, 19.3, W, and 19.50. So the numbers on the last row are the theta values. So we ask to select the consistent ones and then find the average theta used. We go to the solution. We'll now look at 1AIII. The theta values from our calculations, I is 19.00, 2, 19.30, 3, 19.80, 4, 19.50. Remember that the third one, number 3, is unknown, and that's the W, which we have calculated as 19.80. So we fix it there. Now, from these values, the consistent ones are only 19.30 and 19.50. How do you know the consistent ones? The values that do not differ by plus or minus 0.2, that do not differ by more than plus or minus 0.2 are 19.30 and 19.50. So these are the correct theta values. Then using find the average VB becomes 19.30 plus 19.50 over 2, or in centimeter cube, and that will give us 19.40 cm cube as the average theta value, or average that endpoint, so to say. So we'll now go to the next question. We'll now go to the B part of the question. It says, from the information and results above, calculate the I concentration of B in mole per dm cube. From the information and the results above, calculate the I concentration of B. Remember that B is Hz here, in mole per dm cube. So let's take the question one after the other. Let's take one before we go to two. So we'll go to the solution. So 1BI, we're looking for concentration of B in mole. That is the symbol for concentration of B in mole per dm is CB. That will have CB there, question mark. CA is 0.150, 0.105, which is given to us in the question. And remember that A is calcium hydroxide. VA 20.00 cm, which is also given to us in the question. As you can see in the question, you can see at this line 0.0150, 0.105 mole per dm cube of calcium hydroxide. And then the volume is 20.00, and that calcium hydroxide represents our A, and that's the base in this case. So go back. So our CB, our CA is there. Then VA is 20. We'll go back. Our VB is the average theta value that we got from the previous question, which is here 19.40. So that is our VB. VB represents that seed. Then our NA and MB, going to balance the equation, NA and MB. Remember that A in this case stand for the base and B stand for the acid. So you go to the equation, to the balance equation. This is our A. A is the base. The mole is 1 mole, and B is the acid, which is 2. So the ratio of NA is acid, is the base. A to B is 1:2. So that's the mole ratio, which is written over there. So we're looking for our CB. We apply the titration general equation that connects moles to concentration. CA times VA all over CB times VB equal to NA over MB. We'll now make CB the subject by multiplying. CB now becomes equal to CA times VA times MB all over VB times NA. We make a substitution. The value of our CA is 0.0105. We bring it down there. The value of our VA is 20. We bring it down there for substitution. Then the value of our MB is 2. We bring it down there. The value of our VB is 19.40. We substitute for it. The value of our NA is 1. Look at it here. We'll now bring it down. And then solving this out, our CB becomes 0.216 mole per dm cube, to 3 significant figures. We go to question 1B. You can see the solution. Question 1B says we should calculate 1BII, concentration of B in gram per dm cube. Concentration of B in gram per dm cube, which is otherwise known as the mass concentration. We'll now go to the solution to that 1B. So going to 1B, we'll now see we're looking for the symbol for concentration of a substance in gram per dm cube, written as PB, but that P is pronounced as rho. Rho B, the small letter B, and then subscript B. Concentration of in gram per dm cube. We'll have to find the molar mass of B. B, remember, is HCl, so don't get confused. The molar mass of B is substituting for atomic mass 1 plus 35.5. That gives us 36.5 gram per mole. 1 plus 35.5, 36.5 gram per mole. The molecular mass, the atomic mass of chlorine, 35.5, not 35. So you add, you have 36.5 gram per mole as the molecular mass of HCl. Then we'll now concentration in gram per dn cube. The formula for getting this again as concentration in mole per dn cube, which is C times molar mass. So we now have it as that C concentration in gram per dn cube. P is center as saying PB equal to CB. Concentration in mole per dn cube times molar mass. So value of our CB have been calculated before in the previous question as 0.216, and the molar mass of HCl is at 6.5. So when we apply to value to 0.216 times 6.5, we now get 7.88 gram per dn cube as the concentration of B in gram per dn cube. Taking it once more, considering we'll have to find the molecular mass of B, which is HCl, using the atomic mass of hydrogen as 1, chlorine at 5.5. You add it, you have 36.5 gram per mole. So our error is corrected there. The question paper shows chlorine as 35, but the right value should be 35.5. You now have 36.5 gram per mole. So now the molecular mass of HCl. And then considering gram per dn cube, which we call rho or P, is equal to considering mole per dn cube, which is C, times molecular mass mm. So PB becomes CB, which is the concentration in mole per d times mm, which means molar mass. Then substitute the value. The value of CB was obtained in equation 1bi as 0.216, and the molecular mass of HCl is 36.5, which we have saw before. When we apply these values, we'll now see that mole cancels mole, remaining gram and per dn cube. We now have 7.88 gram per dn cube as our answer to question 1bii. We'll now go to question 1b which says we should calculate the mass of calcium ions. Mass of calcium ions present in each 20.0 cm cube of calcium hydroxide. Mass of calcium ions present in each 20.0 cm cube of calcium hydroxide. That is question number B-triple-I. So go to the solution. So the volume we are dealing with is 20.00 cm cube. Got it VA because calcium hydroxide present solution A. Then the concentration of calcium hydroxide Ca given the equation is 0.105 mole per dn cube. First of all, we have to find the molecular mass or molar mass of calcium hydroxide. We substitute the amount of calcium is 40, then open a bracket, oxygen is 16, hydrogen is 1 plus 1, close the bracket, and multiply by the 2, which is as a subscript there, multiply by 2. Then solve for the molar mass. I now have 40 plus 16 plus 1 is 17 times 2 there. So that gives us 40 plus 34, and that gives us 74.0 gram per mole. So first of all, we're going to find the mass of calcium hydroxide present in 20 cm cube using that formula there. So we make M is mass all over mm, molar mass, equal to C is concentration, V is volume over 1000. We make Ma the subject. Ma becomes CV times molar mass over 1000. Then substitute the values from the data given above. C is 0.105, volume 20, molar mass 74, all over 1000. Solving out to have 0.155 gram of calcium hydroxide. So we have 0.155 gram of calcium hydroxide present in 20 cm cube of solution. So our interest is to find the mass of calcium inside this. So we'll now go and we'll write mass of calcium ion in 1 mole of calcium hydroxide. Remember that there is only 1 atom of calcium here, and the mass of calcium ion is there becomes the molar mass of calcium, which is 40 grams. So mass of calcium ion now present in 20 cm cube of the solution now become 40, which is the mass of calcium atom or ion all over the molecular mass of the calcium, which is 74, times 0.11155 grams, 0.155, which is the mass of the hydroxide inside 20 CNQ. So 40 over 24 times 0.155 will give us 0.083 gram of calcium ion as our final answer. So you can go through the work and see that there's no error in it. All right, we'll move to number 2 part of the question. Number 2 question is drafted from qualitative analysis. Now, number 2 says, let's look at the question first. Tests were carried out on 2 simple inorganic salts. C, that C is made bold, and D also made bold. The results of the test are presented on the table below. You have a serial number. You have a test C plus concentrated H2O plus strong heat. We have a cuprous brown irritating fume which turned moist blue newspaper to red. We are asked to fill the inference. So let's go straight to the solution at once. So we'll still look at the solution. C plus concentrated H2O plus strong heat. A cuprous brown irritating fume. Which turn moist blue newspaper red. So our inference, that's the question. The underlined answer is the inference. Inference, fume is NO2 gas. NO2 is nitrogen oxide gas. Then under it also fume is acidic. So that is the inference here. Fume is NO2 and then fume is acidic. This should be the answer to the first question, 2AI. Okay, we'll now go to the next question. Which is 2BI. Okay, says C plus water plus sodium hydroxide in drops. Then in excess, the observation we have to fill. There are 2 lines there. Observation. So you're going to feel what happens when you add C and water and the hydroxide in drops. Then the next line is when you added the hydroxide in excess. The inference will have a aluminium ion or zinc ion. So we'll go to our results and then see what the inference should be. The observation will be in this 2B. So going to the result of this 2B. C plus water plus NaOH in excess. So our observation when added in drops should be white gelatinous precipitate. Precipitate, PRECIPITATE. The word gelatinous must be there for you to score. And the in excess, precipitate dissolved, which already given to you, already given the equation, what is given or not. Then the inference has been indicated in the equation already. So you are filling the observation. Why gelatinous precipitate dissolved. That is for question BI. Why gelatinous precipitate dissolved. So we'll now go to the next question. Next question says C solid plus water plus aqueous ammonia in drops and in excess. So we have to feel what happens in drops. In excess, we have been told that the precipitate dissolved. But in drops, what will happen, that we also find out what the question mark is there. The inference already given to us. In the inference, aluminium 3 and zinc or zinc 2 ion. So that is question BII. We'll go to the solution and then see what happens. BII, C plus water plus aqueous ammonia in drops. NSS. We have to fill the observation in drops. In drops, observation should be white gelatinous precipitate. White gelatinous precipitate. Then that's the only thing they want us to fill there. Every other thing was given to us. White gelatinous precipitate. So go to the next question, which is triple I. Triple I says C triple I. So B triple I, not C. Triple I says C solid plus water plus freshly prepared iron 2 sulfate aqueous plus concentrated H2SO4. We're out to fill the inference. So the observation, the inference is given to, or the inference is triazole nitrate 5 ion NO3 ion given to us. So we're out to fill the observation for that B triple I question. So we'll go to the solution and see what we have there. So in the solution, we'll go to the question again that says C plus water plus fresh prepared iron 2 sulfate aqueous plus conc H2. The observation is brown ring formed at the interface. That should be what we should feel under observation. Brown ring formed at the interface. So that why it's underlined. The underlined statements are the answers. Brown ring formed at the interface. So NO3 was given to us. So if you look at the solution, the underlined are the answers. So brown ring formed at the interface is our solution. So for that number triple I, we'll now go to IV. IV says D plus water. Okay, not IV. We'll have question CI. Question CI. D plus water. Observation D dissolve. We have to write the inference. That we have a question mark on the inference. So D plus water, observation D dissolve, the inference question mark is on it. So we have to fill the inference in this question CI. So we'll go to the solution. For CI, D plus water, D dissolved. So we'll have go to the inference. The answer is the inference. What we feel there is D is a soluble salt. D is a soluble salt. D is a soluble salt because it dissolves in water. That's the reason for that. We'll now go to the IIC. II says solution D, solid, that S in bracket means solid, plus dilute HCl aqueous. Then observation, nothing is there. We have to fit the observation. And then the inference says hydrogen sulfide gas. We'll now go to the solution. You can see it underlined. Solutions should be brisk effervescence. Effervescence spelled EFFERVESCENCE. SCENCE. Brisk effervescence, meaning liberation, comma, a colorless gas with an irritating odor of rotten egg evolved. A colorless gas, irritating odor of rotten egg evolved. Full stop. Gas darkens, or you can say gas turns black. Gas darkens led to ethanoate pepper. Ethanoate, ETHANOATE, led to ethanoate pepper. Full stop. D dissolves to give a colorless solution. D dissolves to give a colorless solution. So that is what you should feel on CII. So because the gas is hydrogen sulfide. So we'll go to the next question, which is C triple I, that says solution D, solid, plus sodium hydroxide in aqueous. Sodium hydroxide aqueous in drops. Then in excess, observation, well, has to fill the observation in drops. While in excess, they gave us the observation as precipitate insoluble. The inference is given to us as calcium 2 ion or lead 2 ion. So we are filling the observation in drops when you added sodium hydroxide in drops to solution D. So let's go to the answer. The answer to the question, we'll have okay, in drops, the observation should be white in bracket, chalky precipitate. White, chalky precipitate. In excess, they gave us the observation as precipitate insoluble. Then the inference is not there. The inference on that close, that is on the same line as precipitate insoluble. The inference, you should write there calcium 2 ion present. Already they're giving us calcium or lead. So under it, you write calcium 2 ion present. So having done that, we go to the next question. The next question, which is IV, says solution D, solid plus ammonium carbonate, aqueous. And then we'll have no observation, no inference. We have to fill both observation and inference. So we'll go to the solution. The solution will give, we'll go to the observation. That's IV, is also white in bracket, chalky precipitate. Then the inference, calcium 2 ion confirmed. The inference, calcium 2 ion confirmed. So let me quickly run through this number 2 once more and highlight on where the answers are again. So for A, I, C plus concentrated H2O plus strong heat. The observation they gave is a cuprous brown irritating fume which turned moist newspaper to red. Then the inference, which is what you have to fill, that one is unaligned, unknown, is fume is NO2 gas, and then fume is acidic. So go to number 2, or BI, C solid plus water plus sodium hydroxide in drops in excess. We have to fill the observation, which should be white gelatinous precipitate. Every other, that one is underlined. White gelatinous is GELATINOUS. Precipitate, PRECIPITATE. So every other thing is given to us in that number, except that one. When I go to BII, that says C solid plus water plus aqueous ammonia in drops in excess. Then the observation is unknown. We fill the observation, which is white gelatinous precipitate. That's what we fill there. Then precipitate dissolved. So white gelatinous precipitate should go in line with in drops. The in excess, we now have precipitate dissolved. We go to triple I. C solid plus water plus freshly prepared iron 2 sulfate plus conc H2O. We have to fill the observation, which should be brown ring formed at the interface. We now go to C, question CI. D plus water. We are given the observation D dissolved. We have to fill the inference. The inference should be D is a soluble salt. We go to question CII. Solution D solid plus dilute HC aqueous. We have to fill the observation, and that should be brisk effervescence, a colorless gas with irritating odor of rotten egg evolved. Full stop. Gas darkens led to ethanoate. Ethanoate spelled ETHANOATE, pepper. Ethanoate pepper. Full stop. D dissolves to give a colorless solution, and that is that. We go to the C triple I. Solution D solid plus sodium hydroxide in drops, then in excess. We have to fill the observation. Observation should be white in bracket, chalky precipitate, not white gelatinous. White in bracket, or it's a white or chalky precipitate. That is observation. And we have also to fill the inference. The inference, the second inference, you can see under calcium ion or lead. You have to fill calcium 2 ion present. Then IV, solution D plus ammonium carbonate. We are asked to fill the inference, and the observation and the inference both are unknown. So observation, you write white chalky precipitate. Then the inference, you write calcium 2 ion confirmed. So having done that, we go to question number 3. Question number 3. Question number 3. Okay, that says, consider the following experimental setup shown below. So we have a diagram for preparing a particular gas. We can see water running through a test funnel into a substance in a flask, calcium carbide. We can see sand under the calcium carbide. We have another container labeled L. That container contains acidified copper sulfate aqueous. Then we can also see, gas Y. You can also see another container labeled Z. And that container inside it is water. So the question says, identify by name L, Y, and Z. L, the Y is a gas. So if you look at the diagram, L is a container, a vessel. Z is also a container, while Y is a gas. So let's go to the solution and then be able to figure out what L, Y, and Z could be. So that L, that container where you have copper sulfate as defined, is called Drechsel bottle. Drechsel bottle, that is L. Then Y is called ethane gas. And Z is called pneumatic trough. Pneumatic trough. Drechsel bottle for L, Y ethane gas, and Z pneumatic trough, that for water. We'll now go over to question 3BI. Question 3BI says we should state the function. State the function of I sand. If you can see there is sand here in the reaction flow, or sand, and II acidified copper sulfate in the setup. So the sand and the copper sulfate, what are they doing there? The function of these substances. So we'll go to the solution. You now see 3BI. The sand absorbs excess heat produced during the reaction and prevents the reaction flask from cracking. The sand absorbs excess heat produced during the reaction and prevent the reaction flask from cracking. Then II, acidified copper sulfate, absorbs phosphine and hydrogen sulfide impurities. Acidified copper sulfate absorbs phosphine and hydrogen sulfide impurities. So that is it. Go to the next question. The next question there says we should, CI, write the balance equation of the reaction for the preparation of gas Y. Write the balance equation of the reaction for the preparation of gas Y. So go to the solution now and see where we wrote the equation. So looking at the equation, that is 3CI. You see calcium carbide, that is CaC2, that is the formula. S in solid state plus 2, so 1 molecule of calcium carbide, CaC2, S in solid, plus 2H2O, that is 2 molecules of water. Then bracket L, that L means liquid state, giving us Ca bracket OH bracket 2 aqueous, that is 1 molecule of calcium hydroxide, plus C2H2, then bracket small g, which is ethane gas. Is the balance equation for the reaction. We'll now go to the last question for this exercise that says, describe a chemical test used to identify gas Y. Describe a chemical test used to identify gas Y. And remember that gas Y is ethane gas. So the question is describe. So you don't give a statement. You have to describe how you would do it in the laboratory. So go to the solution for gas Y. So that is CII. Describe the test. Look at the solution. About 10 cm cube of ammonium copper 1 chloride. About 10 cm cube of ammonium copper 1 chloride. Solution is poured into a test tube. Thereafter, the test tube is stoppered with a cork which has a delivery tube fitted to it. Full stop. A tiny gas is then passed into the solution through the delivery tube. Full stop. A reddish brown precipitate would be observed. Repeat it again. About 10 cm cube of ammonium copper 1 chloride. Solution is poured into a test tube. Full stop. Thereafter, the test tube is stoppered, that is covered, with a cork which has a delivery tube fitted to it. A tiny gas is then passed into the solution through the delivery tube. Full stop. A reddish brown precipitate will be observed. So somebody may ask, must I use ammonium solution, copper 1 chloride? Can't I use another solution? Yes, you can still use ammonium silver triazole solution. Ammonium silver triazole solution. The same statement which I made here. You now replace ammonium copper 1 chloride with ammonium silver triazole solution. Then that you replace it. Then the place will now have the same statement. Then the place will now have reddish brown precipitate. Will now write a whitish yellow precipitate. So if you use ammonium silver 1 triazole solution in place of copper 1 chloride, then the reddish brown precipitate should replace with a whitish yellow precipitate will be observed. The same statement, except changing ammonium copper 1 chloride with ammonium silver triazole and then changing reddish brown precipitate with whitish yellow precipitate. So that is it. Then somebody asks, why didn't I use bromine water? Or why did I use acidified potassium manganate? Remember that we're talking about ethyne. So we have to use an ethyne is a terminal alkyne. So we have to use a complementary test for terminal alkyne. So you have to use complementary for terminal alkyne, because if you use bromine water, you use acidified KMO4. Alkenes will still produce similar results, but alkenes would not react with copper 1 chloride in ammonia solution. Neither would they react with ammonium silver triazole solution. So we have come to this NABTEB GCE chemistry solution 2023 November chemistry practicals. So stay tuned in this channel. Be connected. If you are not subscribed, as I want to say it again, subscribe. Go to the channel's name, Best Science Brain. Under it, you see the subscription button. Sometimes it appears as subscription, or you see a kind of tiny bell on it, close to it. Tap on that bell or on the button only once and get subscribed. You'll be seeing our videos, solutions to examination questions, and also you'll also be seeing tutorials on chemistry, physics, and further mathematics. So remain connected and stay tuned.